Hi, and welcome back. It's time for our last session of day one on the Saturn track at Build Stuff 2021. And I would like to welcome to the stage Yury Niño. Hi, Yury.
Hi, how are you?
Not too bad, thank you. How are you doing?
I'm doing well, thank you. Thank you. I'm very excited. I'm very excited to be here. Thank you.
Awesome to have you here. Now, Yury is a cloud infrastructure engineer at Google, and she's going to be telling us why software engineers should build a resilience culture based on chaos engineering, and I can't wait. So, Yury, take it away. The floor is yours.
Great, thank you. Thank you very much. So, hi everybody. Thank you for being here, and thank you for coming. It is an honor to be here. So the title of my talk is Why Software Developers Should Build a Resilience Culture Based on Chaos Engineering. So nice to meet you. I am Yury Niño, and I work as cloud infrastructure engineer at Google. Also, I am site reliability engineering and chaos engineering advocate in my country. I am promoting the adoption of those disciplines in Latin America. And I am from Colombia. I'm based on Bogota. So according to the last InfoQ report, building for resilience is vital for modern distributed systems where any individual component could fail, and the overall system should remain available. This idea is not new, but just becoming very important as distributed systems and modular architectures are more common. So Daniel Bryan referred to this in his more recent book, Released, a good source for ideas regarding circuit breakers, timeouts, retries, and other fundamental requirements for a resilient system. We have studied the resilience topic since 1970, when David Parnas, the Canadian early pioneer of software engineers, developed the concept of information hiding in modular programming, which is an important element of object-oriented programming today. But what happened with us, the humans, should be resilient also? That is the question to be here. So if for SLAs, there isn't such things as 100% of time, what do humans should be available all time? That is my question. If the system has this issue, why the humans should be available all time? I was wondering about this for several days, and that is the story that inspired this talk. So knowing, my apologies, knowing this, in the next minutes, I am going to explain why our software requires resilience. I am going to remember some patterns for resilience in systems. Here, I am going to introduce a discipline for testing those patterns. And I am talking about chaos engineering. With this context, I am going to explain why building software is complex. I am going to tell you a story about our brain. This is about how we construct mental models when we are developing software. Then I am going to explain why developers need to be resilient and how to cultivate resilience. Specifically, I am going to talk about chaos engineering and chaos game days and how you can use it building a culture based on resilience. So let's begin talking about how do we build software. Building Software and Reliability System book is an excellent reference for studying about resilience and reliability in each development stage. For example, the book explains the principles for designing for resilience, which are perfect and equally important when you are implementing a system. I am talking about these principles: design for less privilege, design for understability, design for changing landscape, design for resilience, and design for recovery. If you, as you notice, the resilience is present while you are designing software. And in the same way, when you are developing software, this book also presents several principles that guide developers toward implementing more resilience code. I'm talking about choosing the proper programming language, knowing the difference between complexity and understandability, securing third-party software. When you are using third-party software, it is important to secure and avoid vulnerabilities present in these components, testing code, identifying weakness, and data validation. And finally, implement patterns for resilience. That is really, really important when you are designing and implementing software, because the resilience is important, as I mentioned, when you have to face a failure on production. So it's really important to consider these patterns and these things when in the earlier stages and the implementing stages. So as you can see, the resilience is present in several implementations. Our applications must be resilient. It is a fact that our code will inevitably include bugs. We could have issues with the hardware, software dependencies, libraries, and anything that compose our systems. So in consequence, with a high probability, our applications will fail. The good news is that we can avoid resilience and reliability issues by using principles, practice, and patterns. Wherever practical, if we keep our code clean and simple, there are a great book talking about this, Clean Code, for example, we can minimize the probability of failures. So with resilience patterns, such as timeout, circuit breakers, file paths, handshaking, governor, test harness, I would like to have more time to talk about this, but the main topic in this talk is resilience. But they are great patterns for guaranteeing resilience in our systems. We can provide the architecture and design guidance to reduce, eliminate, and mitigate the effects of cracks in the systems. I would like to have more time for talking about this, but we have to move to the main topic. So as you can see, there are a lot of patterns, and some of patterns are really complex. That is the reason that although without the best efforts in any moment, we could have an outage in production. So presently yesterday, I had a big outage, a big fire in my job. So that is common with our systems of productions. It is not easy to keep our software free of defects and in consequence of failures. Presently, Feline, the author of this great book, titled The Programmer Brain, she explains, or she talks about this, how confusion is part of programming. Confusion is related to the different types of cognitive processes. A lack of knowledge is related to an issue in our long-term memory. A lack of information is associated to an issue in our short-term memory. And a lack of processing power is caused by an issue in working memory. That is, they are three different types of memories that she used in this book for explaining why our system failed and our brain as programmers works when we are facing a failure on production. The first cognitive process that is used while programming in a long-term memory. This can store your memories for a very long time. The second cognitive process involved in programming is short-term memory. Your short-term memory is used for briefly hold incoming information. For example, when someone reads a phone number to over the phone, for example. And finally, the third cognitive process that plays a role in programming is working memory. This is where new thoughts, ideas, and solutions are formed. If you think the long-term memory as a hard drive and the short-term memory as the RAM. So the processes happen in our brain. It's really important when we are trying to develop resilience in our behaviors, for example. Our brain does a lot more while you are building a program. You are mentally trying to debug and execute code to understand what is happening. That is the happen when you are facing a failure on production also. The mental process for compiling and executing a code is called tracing. Just a friendly reminder that the part of the brain used to tracing and other cognitively process or complex tasks is called the working memory. So when we are building software or solving issues in production, it is important to consider another concept, the mental models. Mental models are simplified representations of reality. And the main goal of a model is to support you in thinking about a problem and ultimately also solving the problem. It is important to consider that people can hold multiple mental models and we have different ways, for example, to resolve or solve a problem that can compete or be compatible with each other. Using explicit models of code when you are solving a problem has two benefits. The first one is the models can help you communicate information about the solutions to others. And the second benefits of models is that they can help you solve problems. In this sense, by anticipating mistakes like failing, can eliminate redundant work, and after that, the bug fixes. It is okay, but the question is how to prove it works. So we were talking about failures, about issues, about our brain works when we are solving problems. So that now is the moment to talk about how test or how prove that it works. That my answer is using chaos engineering. So chaos engineering is the discipline of experimenting failures in production in order to reveal the weakness and to build confidence in their resilience capability. This definition was taken from the website of Principle of Chaos that contains a manifesto for chaos engineering in many languages. That is a great source if you want to study about chaos engineering. So I like to see chaos engineering as a proactive mechanism for detecting availability black swans before they happen. Chaos engineering is practice following these four principles. The first one is related or regarding to hypothesize about a steady state. Particularly, this principle could be difficult because probably you need to mature software and to be sure that your system is free from many bugs. A second principle is about very real world events. For example, change the values in a configuration file or introduce a high consume of CPU resource in a virtual machine. And in a third step, we should run experiments verifying hypotheses when the server crashes, network connections that observe, or anything that you change in the previous principle. And finally, it is about automation. If you want to repeat this methodology many times, you should consider try to automate these experiments using pipelines, for example, or scripts or sophisticated tools like we are going to review later. So let me move to a short story about chaos engineering. Chaos engineering first became relevant when Netflix engineering team created Chaos Monkey in 2008. Chaos Monkey was created in response to Netflix move from physical infrastructure to a cloud infrastructure provided by Amazon Web Services. In 2014, while Carlton Andrews, who was part of the first team that worked in chaos engineering, left Netflix, his team announced failure injection testing, or FIT, a complete platform for practicing chaos engineering. At this moment, Colton Andrews is the CEO of Gremlin, the most important company that provides chaos engineering services and training related to that. Since 2018, it has a massification of the discipline around the world. So now we are more than 5,000 persons in a community in Slack, for example. I am going to share the link or the URL to connect to this community in the final of my presentation. The last milestone was the publication of a book in April of the last year. The book was written by Casey Rosenthal and Nora Jost, who were part of the original team working in chaos engineering nodes. It is a phrase taken from the last book, Chaos Engineering, from Casey Rosenthal and Nora Jones. Humans are central to both the problem and the solution in a system. I extended this definition to in incident management, because when we have a disaster on production, for example, people is the reason there is a need and solution to solve the problem. In this sense, humans are fundamental when we are facing a critical situation such as an incident, because we are central, we are both the problem and the solution. So the interactions between them, between us, to answer questions like how can we create software that people can effectively operate to achieve that goal. It is known that when we are not punished for speaking up with ideas, questions, concerns, or mistakes, we feel comfortable being ourselves. A lack of that is related with psychological safety. Psychological safety, a concept developed by David Alton, because a lack of psychological safety has major business repercussions. When people don't feel comfortable talking about initiatives and aren't working, the organization isn't equipped to prevent failures. And when employees are in full commitment, the organization has lost an opportunity to leverage the strengths of their talent. People need to feel comfortable speaking up, asking questions, and disagreeing with anything. And when we are facing a failure in production, they are really important concepts to consider in order to find a proper solution for the incident. So it is really important. It's really important to consider safety when we are facing failures. So here are some definitions for resilience. So at this moment, I am going to move to another important concept, resilience engineering. So as I mentioned, I was talking about failures, I was talking about chaos engineering, and now I am going to talk about resilience engineering, an important concept when you are facing failures that you can test with chaos engineering. So here are some definitions for this concept. Resilience is the ability to positively adapt to difficult situations and overcome adversity. A lot of people adapt to stress negatively. The difference with resilience is that positively adaptation is key. So resilience includes both physical and mental positive adaptations, though for developers, it is important to primarily look at the mental side. Software development is filled with mental challenge, as I mentioned, and as Pelin mentioned in her book. Resilience sounds like something that you want by when you need it. That is the question for here. Because one of the most important competencies for developers is to develop resilience. Resilience is defined as an intrinsic ability of a system to adjust its functioning prior to, during, or following changes or disturbances. That is okay for the system, but what happens with us? What happens with humans? So resilience engineering considers those topics and consider that resilience is critical for organizations, as critical for humans, as critical for people who are facing a failure on production. It provides an excellent approach to manage people when we have to adjust a system during or following disturbances in the proper function, in the proper working for a system. Resilience refers to a quantity rather than a quantity. That quality rather than a quantity, my apologies. So managing resilience can be seen as a kind of process control. A literal definition is that resilience is the ability to have a human to adapt itself due to the failures or anomalies in a system. The definition can be made by considering 4 essential capabilities, 4 key concepts here: actual, factual, critical, and potential. that together constitute the capacity to respond or to learn, to monitor, and to anticipate an emergency or a critical situation. So I would like to share this screen because in performing these activities, the human factors are really important here. And there are a lot of fields in science and in engineering that consider resilience and that consider these topics I was talking about. In performing these activities, humans are required to follow procedures, interact with controls and displays, interpret information, and communicate with others while they are solving problems in a critical situation. Therefore, human factors are a subject of many fields in the science and engineering. So it is important to consider procedures, workflows, staffing levels, competences, and supervisions. That is good reason for human factors have been studied in many years ago in fields as medicine, aviation, law, space, construction, meaning there are a lot of fields that consider resilience in their procedures. One of my favorite applications of human factors is on aviation. So it took this competence, which we established through a review of literature, considering the procedures when the pilots are facing a critical situation in their jobs. So when we are facing an emergency, it's really important to be able to construct and maintain an adequate mental representation of the situation. Also, we should be able to assess risks and threats are relevant of the flight. For example, when we are using an analogy with a critical situation in a flight, and in the same sense, to switch from a situation under control, and to be able to maintain a relevant level of confidence in a crisis situation is critical. For guarantee these abilities when we are facing a failure, it is really important to guarantee psychological safety, guarantee resilience, and guarantee the people involved in the situation have the proper abilities to solve the problem. So there are more important competencies to develop. We should be able to make an intelligent usage of procedures, and we should be able to use available technical and human resources and to reconfigure them, because in this moment probably those things could be failed also. Also, we should be in capacity to manage time. The time is really important here, and the time pressure also. It is very important to be able to properly transfer knowledge and know how from a specific context to a different one. And finally, we should be able to properly use and manage information and communication technology equipment. Because if we have a lot of tools in a critical situation, it's really important to know how to use them and to have the capability to manage the time, the pressure, managing these tools. So considering this, it is the moment to move to Chaos Game Days. But I would like to share this phrase taken from Aaron Reinhardt. Aaron is a great author who is working with security chaos engineering. So he talked in a previous talk, humans operate differently when they expect things fail. So it is really important to face the failure before the failure happens. And game days were created by Jesse Robin, and they are a great tool to develop resilience before the failure happens. It is a great strategy to training, for example, to train engineering teams. So Chaos Game Days were created by Jesse Robbins, an American technology person, entrepreneur, and firefighter, notable for his contributions in wearable communication, web operations, DevOps, and emergency management. Jesse Robbins worked for AWS when he developed this this type of strategies to manage and develop resilience in an engineering team. So he is designed several strategies and several games to develop resilience. So let me talk about this. Although there are several ways to run a chaos game day, this is the most common. It is based three roles. A master of disaster who decides, often in secret, what sort of failure the system should undergo. He or she will generally start with something simple like loss of capability or loss of connectivity, with the team gathered in a room or physical or virtual. The master of disaster declares start the incident and then calls the planned failure. One member of the team asks the person called and attempts to see, triage and mitigate whatever failure to the master of disaster has caused. And when that has been done, the time allocated for response has ended, the master of disaster will reserve the failure and the team will proceed to a postmortem of the incident. That is the strategy, for example, to develop a game day in a company, using these three roles: master of disaster, person call, and team that finally solve the issue and create a postmortem about the previous activity. So we are talking about a chaos game day. We are talking about three phases: before, during, and after. Before the event, it is important to pick a hypothesis. If you remember, I told you about a hypothesis when I mentioned the principle of chaos engineering, and pick a style. The previous slide is an example of a style, but there are more styles for running chaos game days. Decide who, decide where, decide when. That is things related with planning, and document and get approval of your manager, for example. During the chaos game day they are the activities for running a chaos game day. Detect the situation, take a deep breath, communicate. That is really, really important, that company knows that we are running a chaos game day or a chaos or a planet failure, because if we want to avoid more chaos in the experiment or more chaos in the chaos game day, it's really important to communicate to the people involved and in the company. Visit that dashboard. Providing observability is really important here. Analyze data, propose solutions, and apply answers. And after that, it's important to write a postmortem, because it is a document that resumes the activity and provides learnings about what happens, that our memories for this event. And it is important to include in a postmortem what happened, the impact, the duration, the resolution time, the resolution strategy, timeline, and action items. The action items, they are the most important thing here, because they content, they have the learnings about this activity. So if you want to start with resilience engineering and chaos engineering, they are my recommendations. The blue books from Google, in which with a framework site reliability engineering was proposed. This book have a lot of information related site reliability engineering, another concept, but related to chaos engineering and resilience engineering also. Because if you want to provide reliable systems to a company, it is important to provide resilience for your system. But that is more important to provide resilience for your teams, for your people, because people are solving the problem. So it's really important to provide here these capabilities or this skill for your team. That is my point here. So my strategy is using chaos game days, that is a topic related to chaos engineering, a discipline to experiment with failures in production. So the other books that includes my recommendation, another book from Google is Building Secure and Reliable Systems. If you remember, I talked about this book in the previous slides. Remember that is important to include resilience while you are designing, programming, and providing testing in your systems. So this book is related to that, building security in your systems, and how reliability and resilience is important here. So learning chaos engineering from rules miles that provides a complete context for discovering system weakness through experimentation. That is a great book if you want to learn about experimentation, about hypotheses, about experiments. Learning chaos engineering is the proper book. And the other book included here is Chaos Engineering, the first book provided by the team who developed this theory in Netflix. Cassie Rosenthal, Nora Jones, Aaron, Lauren, and Colton Andrews, who creates Gremlin after that. That is the great reference for a start with chaos engineering. And finally, the chaos engineering book included published in the previous years. So as I mentioned, that they are links to study about chaos engineering, to study about how you can use another chaos game days styles for providing resilience for your teams. So the first one is the chaos engineering Slack, that includes information, that includes contacts in order to build a community related to chaos engineering. So the other one is also included in GitHub, with information about chaos engineering, about resilience, about the strategies, about tools. For example, Gremlin built a great tool for providing chaos engineering attacks in your productions, in your systems on production. And finally, a great channel included in InfoQ, a great reference for us who are developing software. So that is all. They are my contact data. You can find me in Twitter, in Medium, and LinkedIn as Yury Niño. And that is all. Thank you very much. And I hope that you experiment with your system and provide resilience in your engineering team, because that is really, really important for us, for humans. Thank you.
Awesome. Thank you very much. That was an amazing whirlwind tour. There was so much to take in that time. And one thing which really struck me with everything that you were saying is what you were talking about, the psychological safety. I think that's something that we really don't give as an industry. We don't give enough credit to that inside of our teams, and the amount of different facets of software development where that comes back into play is, immense. It's everywhere.
Yeah. That is a great concept. That is really important to include when you are creating a safer space for your team, for your colleagues, for the people involved in your daily activities. Because if you feel safe in a company, probably you develop your all talent for solving issues on production. That is the case, the use case I was talking.
Yeah. And it's we don't have any questions in the chat that I can ask you. I did want to ask you a little bit more about the chaos game days, because that concept is new to me. I quite like it. That's quite cool. I'm guessing that is setting up an environment that you can go ahead and kill. Is that the idea there?
Yeah. That is the idea. The idea is to face a failure in a control mode. That in this case, for example, I was explaining a master of disaster is a person who provides an attack, and the other team try to solve it, but in a safe space. We know that we are running an experiment and running an exercise in which not is critical for the business, for example. But we are facing the issue previously. This happening on production. So, for example, in security is related to blue and red team exercises in which we face a failure before that happen, but in a control system. So there are several strategies. Then another strategies, for example, in which the team is divided into teams, and one team attack to the other team and providing failures, and the other team try to defend of these failures. And that is important because, for example, while the experiment is running, we can create strategies for communicate the ideas to know how the other works, how do the other manage the pressure, for example, and that is important. But that is a strategy provided by AWS. For example, they run this type of exercise frequently, and that they are free, and you can go to Google or any tool to find about Chaos Game Days, and you can see there are a lot of this exercise and a lot of literature related to that. Another company that provides Chaos Game Days is Gremlin. Gremlin, I was talking about Gremlin, who a company created by Colton Andrews. Colton Andrews was part of the first team in Nectis. So the company provides tools and references to running this type of exercise, in which the idea is to launch an attack for the infrastructure or for the software, and the other team try to solve the issue in a safe space, in a safe environment.
Awesome. Well, I'm going to be taking a deeper look at that. I have so much that I want to take a look at from today, and it's only the end of day one. It's going to be a very busy time for me after this. We have a comment in the chat from Vladimir. Good session, thanks. And yeah, I can only echo that. I thought it was a really interesting session. I have seen a lot that I need to learn, and I would like to thank you very much for your time.
That is an honor to be here. So I have a few minutes more, but that is really, really awesome. That is a pleasure to be here, and that is an honor for me. And welcome to Colombia, welcome to Bogota. If you have the opportunity to visit us, you are welcome. Thank you. Thank you very much for this opportunity, and for this opportunity to share our learnings about failures, about chaos engineering, about Chaos Game Days. And I hope you can experiment with your systems using, for example, Gremlin, a great tool for that, if you want to review more about this in internet.
Awesome. Well, thank you.
Thank you.
And